All right, so let's try to finish up this section 1.5. We stopped at congruent segments. All right, let's talk about this next thing. Let's make a line segment. All right, and let's label it. Let's put a point at the end. Since this is a line segment, it does have a start and a finish place. They're both called endpoints. So I'll call the endpoints A and C, and then I'll put another point in here somewhere, and we'll call it point B. Now, at first, this doesn't seem like it's that big of a deal. It's like, well, of course, the word that I'm going to show you is the word that I'm going to talk about. But you're going to see how it's being used. What they do right here, if you have two endpoints, A and B, and you got some points somewhere inside of A and C, somewhere on that line segment, we say that the point B is between A and C. That kind of makes sense, doesn't it? Right? You got thing here, you got a town A, town B, this point, this town's right here, it's somewhere in between. Does it mean it's like dead center, halfway, if I say between? No, it could be anywhere. It could be like right here. That's still between A and C, isn't it? Okay, or it could be like right over here, or it could be dead in the middle, right? Anywhere where A is to the left and C is to the right, B will be between, all right? So that's the word that we're gonna talk about. It's pretty easy to understand, but here's what they really want you to see. It's not just knowing the word between. If B is between A and C, that means that this is true, that AB, let me see how they write this. Yep, AB plus BC equals, what do you think? Now, let me ask you this first, before I ask you that question. If I just see an A and a B next to each other, this is one I said that a lot of people forget. Okay, it's pretty simple, but a lot of people forget what this means. There's no like symbol on top of it. I didn't put a line segment, I didn't put a ray on top, I didn't put a line on top. But if I just have an AB, what does that mean? What does that tell us specifically? Very good. It's the distance. It's the length of. Okay, it's the same thing. Means the same thing. The distance between A and B, or the length of AB. All right. That's kind of how I want you to say it, though. The length of AB. So if I was to read this, if I was to write it down in words, and I wanted everything, I want to use the correct word for everything. What would I say here? The what? The length of AB plus the length of BC equals. So watch. If I take this length. Let's just give it a number. Let's make up something. 30? Okay, we'll make it 30. All right. What do you think this length might be? 10. Yeah, let's say 10. 10 looks appropriate, okay? So what if this was 30? The length of AB was 30. I'm just saying if it was, okay? I measured it, it's 30. And then I measured BC, and it's 10. 10 what? Inches, millimeters, centimeters, I don't know, whatever it is. The length of AB plus the length of BC is going to be what? It's going to be the same as the length of AC, correct? All right, because AB was what? 30, and then BC was what? 10, and that's going to equal what? 40. So what, now, if they said find AC, and that's all they said. They say find AC. Again, what does that mean? It means find the length of line segment AC, how long it is, okay? In this case, we could do it. We have enough information, don't we? So we would just say AC is what? 40. As simple as that, all right? Does that make sense? All right, so when you don't see the line segment over top of it, that means it's the length of that particular line segment. Does that make sense? All right, now, that was pretty easy. 30 and 10, 30 plus 10 is 40, easy, right? Now, I think this is your first algebra that you've done in geometry. All right, it's the same kind of deal. We got a line segment, and they have a point that's between, and they still call it A and C, all right? So we'll use the same letters. So there's A, there's C. This time B is going to be right here. Now watch what they do. They don't just tell you that's 10 or 30 or whatever we said. Watch what they do on this one. They say that AB is 6x minus 1. That's a little weird, isn't it? Oh, gosh. I hear the moans already. And then this one is 5x plus 10. All right? And what we want to do is we want to find the actual length of actually three things, because we don't know any of them right now, do we? As far as like an actual number, right? 30, 10, 40. Do we know any of those? No, because you got the x's in there. You don't know what x is. So guess what we're going to have to do? We're going to have to solve for x. Exactly right. And this is what we do. This is the first time we've done it in geometry. We're going to be doing this throughout the rest of the course. Something very similar to this, okay? Something very similar to this. We're going to take the geometry that we know, we're going to take some algebra expressions, and then we're going to put them together. Sometimes this is equal to this. Sometimes this plus this equals something else, all right? We're going to put them together, and we're going to come up with something. I forgot one thing, because there's no way you could solve for this without knowing this. They tell you sometimes, let's see, do they use that word here? No, this is how they say it. They say find AB and BC. Now they do tell you one other thing. So they tell you how long AC is with an actual number, not in terms of x, is 75, okay? So they tell you that whole length right there is 75. I got to figure out what is this length and what is this length. Let's say we found one of the lengths and we actually got a number for it. How would you find the other length? Subtract from 75, exactly right. Yeah, the whole thing's 75, right? So if I find AB, whatever number that is, then how do I find BC very easily? Just 75 minus AB. Or the other way around. If I find BC first, how do I find this little AB? 75 minus whatever BC is. Everybody got that? Make sense? All right, so let's figure out what we're going to do. Well, what does AB and BC do? Look, what did they do right there? AB and BC did what? They added up to be AC. Well, we kind of know AC. Not kind of, we actually do. We know AC. So what can we say? We can say that AB plus BC equals 75. Now that alone doesn't help, but I kind of know what AB is equal to, don't I? Problem is, I don't know what x is, but I kind of know what AB is. What is AB? You got it, 6x minus 1. Now what are we doing to the BC? We're adding it, right? So we add BC. What's BC kind of equal to? I shouldn't say kind of equal to. It's absolutely equal to it, but we don't know exactly what the number is. That's why I say kind of, right? Does that make sense? So what is BC? You got it, 5x plus 10, and what's all that equal? 75. Now, we've set up a little algebra equation, and now what do? We solve for, what do you think? Solve for x, okay? And this is why you took Algebra 1 before you took geometry, so that you can do this stuff. Remember this from last year? Okay, so let's add some, what do we call it? Like terms, right? We're going to add some like terms, so let's do that. I got a 6x and a 5x. What's 6x plus 5x? Very good. That's 11x. And then we take our regular numbers, okay? The negative 1, that's a minus 1 or a negative 1, agreed? All right, so I take negative 1 plus 10. What's negative 1 plus 10? Positive 9, very good. And that equals 75. Make sense? Everybody good with that? All right. Hopefully, honors geometry, you had a pretty good grasp of Algebra 1 before you came in here. And really, I mean, it does get a little more complicated than this eventually, but really not much. I mean, you're going to see this kind of algebra a whole lot in here. So if this is good for you, and you're like, oh yeah, I got this stuff, that was easy stuff, then that's cool. Then geometry is basically just taking a bunch of shapes and different things like that, and then either, like I said earlier, setting them equal to each other, adding them up, setting them equal to something else, right? And that's exactly what we're doing. So this is a big, big part of geometry, is what we're doing right here. You take the shape, in this case it's just a line segment, but you take the shape, you do some stuff to it, and then you do some algebra, you solve for x, and then you plug it back in. All right? And that's really geometry in a nutshell right there. This one little problem. Obviously it gets a little more complicated, but it's basically just like this. Let's keep going. We want to get x by itself, so what do I get rid of? How do I get rid of it? Subtract a 9. Very good. And what's that? 75 minus 9? 66, right? And then one more step and you've got x. What do we have to do? Yeah, divide by, how about 11, right? I know what you're doing. You're giving me the answer. That's fine. X equals, now you can say it, 6. Is that our answer? Do we write that down? Do we circle it and we say, yep, we're finished? Nope, because what do they ask you to do? Find what? Not just AB, find the length of AB, all right? Find the length of AB and the length of BC. So I know what X is, so let's do AB first. So what am I going to do with this? Yeah, now I know the X, so I'm going to plug it back in. Exactly right. All right, so I've got 6 times, let's do this, AB equals 6 times what? 6, and then minus 1. You can do this in your head, can't you? 6 times 6 is 36. 36 minus 1 is 35. So AB, that equals is kind of in a weird spot, isn't it? Let's fix that a little bit. All right, so AB is 35. Now, I got a choice of how to find BC. I could take that 6, plug it back in for the X. Go ahead, say it. Yeah, that's the choice. That's the choice, okay? So I said one of your choices could be just taking that X, putting it into here, but look all the math you got to do. You got to first substitute it in for here. I thought I saw one this morning, but maybe somebody took it because I'm pretty sure I saw one, but I don't see it now. So it must have gone somewhere. All right, sorry. All right, so let's we got 2 choices. We could take that 6 and plug it in for this X right here. So let's do it in our head. 5 times 6, 30 plus 10, 40, okay? Or you could have done this. You could have said BC is just equal to what? 75 minus 35. And look at that. You still get the same exact answer, don't you? So you could do it either way that you wanted to, all right? Whatever way. Sometimes it's easier to do it one way. Sometimes it's easier to do it another way. But there you go. What do you think? You like that? Yeah. So it's a little different than algebra because algebra, what would they do if this was an algebra problem? They would just give you this, wouldn't they? And they would just say solve for X, right? You did that a bunch of times in algebra. But this time you actually have to come up with the algebra equation, right? From the geometry, from the pictures and the information they give you, you had to know that these 2 things were added together. Would you set them equal to each other? No, because you don't know that B is right in the middle, do you? Now, we will talk about that. That's got its own word. It's called a midpoint. We'll talk about that later. Sometimes they will say B is the midpoint. What if B was dead in the middle? What would you do with these 2? Then they're equal, they're the same, so you'd set them equal to each other. Exactly right. Does that make sense? But in this situation, you don't know they're equal, but you do know that they add up to be 75. So that's what you do. You add them up, set them equal to 75, put them in there, do your math, solve for X, plug it back in, and you're good to go. Good. Oh, I was just looking at my paper. And the next thing we were doing is midpoint. I kind of figured that was coming up soon. So we just talked about it a second ago. Let's do it. So now, just because a point is between 2 other points doesn't mean it's dead in the middle. If I said B is between A and C, does that mean B is right in the middle? No, it doesn't. We just showed that a minute ago. But there will be times, watch this, if I highlight this little line, I don't know if you're close enough. Do you see a little blue dot right there? Yeah. So that means that's the middle. So I'm going to put a dot right there. All right. So let's use different letters this time. Let's use X and Y. And let's put M. Why do you think I put M? That's weird if I use X and Y. Why did? Yeah, midpoint, middle. Okay, it's in the middle. Okay, and if we want to think of it as the middle, it's perfectly fine. But in this situation, if this is in the middle, or I don't usually say middle, once we learn the word midpoint, that's what we're going to start saying, all right? So I'm going to call this the midpoint. Midpoint. All right, so there's the midpoint. That means that, what do you think? XM, the length of, I should say, the length of XM is equal to, what do you think? The length of my, not just m, that's just a point. Doesn't have a length, does it? But my, or I could call it ym. I'm going to call it ym, is that all right? Just to keep the m second. I don't know why. Doesn't matter though. Makes no difference whatsoever, all right? I don't know, just like writing it like that. So there we go. Actually, in my notes, I did put my. So that's what it means. It means the length of xm is equal to the length of ym. Remember the last thing we did? Look in your notes. What's the last thing we did on Friday? We talked about congruent segments, right? How did I show on a picture if two segments are congruent to each other? Put the tick marks, that's right. Okay, the little tick marks, remember that? So if I put a little tick mark right there and a little tick mark right there, what does that tell you? Just by looking at the picture, what does that tell you about xm and ym? That they're congruent to each other. Or you could say equal. I'm okay if you interchange equal and congruent in this situation. A lot of teachers, technically you should say that they're congruent to each other. You could say xm is congruent to ym. I'm okay if you just say they're equal. Okay, I got no problem with that. So anyway, so you know they're equal to each other. So that's kind of nice. So if these were equal to each other, what do you know about point m? Point m must be the what? Must be the midpoint, okay? And they also add up to be the whole thing. You could still say that xm, the length of xm plus, let's go my like you wanted to. What would that equal? So xm plus my would equal what? xy, very good. The length of xy, all right? And if you stick some numbers in there, even put some variables in there, right? Just like we did that algebra stuff. You could set them up either way. But this is a little more specific than just being between. This means it's between. This means it's exactly the same distance from x as it is to y. All right? I think I've covered that enough. Oh, they didn't even give you an example for that. Did I miss an example? Anybody got their book open? Nope. And then they just go right to the angle stuff, right? Now, you know what they're going to do, though, right? They're going to do something. Now, let's see. Yeah, this would probably work. What if I said, let's use those same numbers. What if I said this is 6x minus 1? What was the other one? 5 what? Plus what? 10. 5x plus 10? Okay. What if I said this was 6x minus 1 and this was 5x plus 10? What would I do? And that's all they tell you. They don't tell you the whole length of it like they told you before, like it was 75. But when you add them together, m's the midpoint. So what can I do with those two things? Look, what's true about that length and this length? They're going to be the same. So what can I do with them? Set them equal to each other. Very good. Okay, set them equal to each other. Does that make sense? All right, so that's what I'm going to do. Watch what xm is what? 6x minus 1. And what's ym? 5x plus 10. All right, and we can go ahead and solve for x. Well, this time it's a little different because the x's are on different sides, but I want the x on the same side, don't I? So I would subtract a 5x from both sides. That's what I would do. Can we do that in our head? So if you subtract a 5x from that, it's just going to cancel, correct? If I go 6x minus 5x, what do I get? I get 1x. Everybody with me on that? Then take that 1. What do I do with that? Plus 1, plus 1. What's 10 plus 1? 11. There you go. So you didn't have to show every single little step, but I showed enough. What do you probably think they were going to ask? They're probably going to ask you to solve for xm, right? So if I solve for xm, what do? It's 6x. What's 6 times 11? 66 minus 1 is 65. Now, without doing any math whatsoever, what would you do? What's my going to equal? It's going to be 65, okay? Let's just double check. Let's put the 11 in for this x. 5 times 11 is 55 plus 10 is 65. And it works. Perfect, doesn't it? You got to go? Yep. It is. So if you have to go, you can go for sports. Watch the video, all right? See what the homework is. look on facts to see the homework. It'll be on the end of this video as well. But that's going to be due tomorrow, so if you got to go now, you can go, but just make sure you get your stuff done. There's really no excuses with me doing these videos to not know what we did the rest of the class. Would you agree with that? All right, so make sure that you do that. All right, enough of that. Let's talk about angles. The whole lesson was what? Line segment, or segments and angle measure. So let's talk about angles. We remember what an angle is, don't we? Remember, an angle is made up of two what? Rays, and they have a common endpoint. And we give a special name for that common endpoint. What do we call that thing? The vertex. Very good. All right, so there's two rays. They have a common endpoint right there, and we call that a vertex. All right? Tell you what, I'm going to make this. I'm going to go like this, just to be, I don't know, I could have kept that angle there. It would have been fine. I'm just going to make it go straight across like that. So we know what an angle is. Now we're going to talk about some special types of angles. You could call this special angles. Special. My writing is terrible. I'm trying to go too fast now. So special angles. This is one of our special angles. Now we have to, there's a way to measure angles, and I'm sure that you've heard of this. What if you had, like, I don't know, this board right there, and see the end of the board right there? See the angle up at the top left corner? Yeah. What kind of angle is that? Right. Yeah, so you guys are used to that, right? How many degrees, that's how we measure angles, using degrees. How many degrees is a right angle? 90, good. So you're used to that stuff, aren't you? So you know what 90 degrees is. What if you had, I'll use this meter stick. Let's say you had two rays and they both started here, where my finger is, this finger, you see that? One ray's going this way, the other ray's going that way. How many degrees is that from here to here? It's 180 degrees, good. Everybody got it, right? So you know at 90 degrees, do I have anything else to show? Let's just use these things, these markers. All right, so this would be how many degrees? 90 degrees, okay? And this would be 180 degrees, okay? And then what about anywhere in between here and here? It's below 90 and it's more than 0. Right, what if these two rays are going in the same direction? What angle is between them? It's 0 degrees, and then it goes all the way to here. I heard somebody say it. What angle is it called when you're between 0 and 90? Acute, and that's what this angle up here is called. And again, this is something you've probably heard before, but we're going to do a lot with this. So if this angle from there to there, usually I just say less than 90, but technically it's really between 0 and 90, okay? Any angle between 0 and 90 or less than 90, I call an acute angle. See how cute it is? Cute little angle. It's acute little angle, all right? So it's an acute angle, and it's less than 90 degrees. Pretty simple. All right, let's do another one. These are all special ones. We've already mentioned this. You already know it, but we're going to write it down anyway. And let's put the arrows on the ends. All right. If this goes exactly 90 degrees, so from here to here is 90 degrees, so it's equal to 90 degrees, then we have a name for that. What do we call that? It's a right angle. Very good. This is stuff you probably learned in middle school. They probably taught you about different angles and shapes and stuff, didn't they? No? They didn't. You didn't learn any of this? Most likely. That's right. You're going to learn them now. So even if you didn't learn them before, it's fine. You're learning them now. It's not that hard, is it? All right, so that's a right angle. See that little box that I put right there? That indicates that it's a right angle. I don't have to say, like, this is 90 degrees. I don't have to do that. I put that little box in there. That automatically means it's a right angle. That's the symbol that we use. Everybody good? All right, let's do another one. This is one that gets kind of lost in the shuffle a little bit. It's got a, there's the point right there, and then there's an arrow, arrow. Now, what do you think about this? Now, if this went straight up, that would be 90 degrees. But this is going more than 90 degrees. So it's greater than 90 degrees. So that the acute angle is less than 90 degrees. This one is greater. I got to slow my writing down because this doesn't keep up with me very well. It's got a little lag. All right, it's greater than 90 degrees. So if this angle from there to there, technically it's between 90 and 180, all right? But I'm okay if you just think it's bigger than 90. So if this is bigger than 90, oh, I forgot to plug my computer up, and now the screen is going dark on me. There we go. And let me, you can't see it, but on my screen I see it went really dark. All right, so this is greater than 90 degrees, so we have a special name for that. Does anybody know that without looking in the book? It's obtuse. Okay, so it's an obtuse angle. Remember the symbol for angle? Looks like that. So that's acute angle, right angle, obtuse angle. So if it's greater than 90, it's obtuse. Obtuse could be used in other ways as well. Like if you really want to make somebody feel bad, you got an argument or something, you want to, instead of saying, well, you're so dumb, you're so stupid, you could always say what? Yes, you're so obtuse. And that's kind of means you don't know what you're talking about. Like you're going the other way, a different direction. I don't know if that's exactly, but that's what people say. Kids don't usually say it. You never hear a kid telling another kid, that's so obtuse. That argument is so obtuse. But even regular, like normal adults probably wouldn't even say that very often. But anyway, just thought I'd throw that out there. You could always look up the definition. I'm not going to right now. All right, watch this. Now these are two different rays. Everybody see that? See I got that dot in the middle? Yeah. And you got it. Yeah, this is a point. Here's a point right here. So one ray's going this way, one ray's going this way. They have a common endpoint, so that means that is an angle. All right? We already said it when I took that meter stick out and showed you. Look, the angle goes from here to here. So it's 180 degrees. So it's equal to 180 degrees. What does it look like? It looks like what kind of a line? Just a straight line. Now, straight line is kind of redundant because the word line itself, the word line itself automatically means it's straight. But a lot of people say straight line. I'm okay with that. It's no big deal. But a straight line is 180 degrees. So what kind of angle do you think we call this? Call it a straight angle. That's right. So it's a straight angle. So how many degrees is a straight angle? It's 180 degrees. All right, so that's pretty important. Let's do some more with angles. Everybody good with that? Yeah. Here's some other words that you've probably heard before. Again, some stuff in geometry you probably never heard before. Some stuff, like the stuff we're doing today, you probably have heard before. Maybe not exactly the way we're doing it now, but you have heard it before. So what if we had this? What if I had two lines that intersect each other, but they intersect each other at a particular angle? So here's a line here, here's a line here, all right? What kind of angle does it look like they intersect each other at? Yeah, it looks like a right angle, all right? Everybody listening? Carly? So if these two lines intersect each other at a right angle, now do every two lines intersect each other at a right angle? No, but sometimes they do. Let's use these markers again. These are always helpful, all right? So if you have two lines that intersect like that, is that a right angle? No, but if I go, boom, right there, that kind of looks like a right angle. Do you see that? If they intersect at a right angle, then we call those lines, we have a special word for these two lines. We say those lines are perpendicular. You've heard that before, haven't you? Yeah. People actually use that word quite a bit. Even in sports, they'll talk about don't run parallel to them, run perpendicular, which means right at them, all right? So a lot of different people will use this word perpendicular. All right, so these two lines are perpendicular lines. We have a symbol for perpendicular. Didn't I show you a symbol for parallel the other day or Friday? we have a symbol for perpendicular. So let's do this. Let's call that point A. Let's call this point B. Let's call this one C, and this one down here D. So if I wanted to label this, all right, here's what I would say. I would say that line AB, now we're not talking about the length of the line now, are we? Because anyway, a line doesn't even have a length anyway. So line AB is perpendicular to line what? What's the other line? CD. Now here's the symbol. Watch. It looks basically just like this, except we just do it a little smaller. It's like an upside down T. That's the symbol for perpendicular. So when you look at it, you don't have to write that whole long word perpendicular. That would take a long time to do every single time. So right now I just say that line AB is perpendicular to line CD. Once they tell you that, automatically, what's true about that angle?
It's right.
That's a right angle. It's 90 degrees. What's that angle right here?
Right.
That's a right angle. What's that one? A right. And what's that one? A right. So all four of them are right angles. I happen to put it right there. You could have put that box anywhere, but that's where I decided to put the box. So these two lines are perpendicular lines. We're going to do a lot of stuff with perpendicular and parallel lines. All right, we're just introducing you to it right now. That's what this chapter is, just kind of introduction to you. The next thing's pretty easy. What if you had this? What if I had an angle? Come on. What if I had that angle right there? I'm not going to put the arrows just for sake of time. Is that all right? So what if I had this arrow or this angle right here, and I took it and I copied it and pasted it and put it over here? So whatever that degree is, I don't know, make up a degree. How many degrees do you think that is?
63.
I heard 60. I think that's pretty close to. I have no idea what it is, and I'm not going to measure it. Shh, listen. So let's say it's 60 degrees. So then, if I copied and pasted it, this is the exact same measure of this angle, isn't it? So if this is 60 degrees, what's this angle? That's also 60 degrees. So let's call this angle R and angle P. All right? Tired of using A and B all the time. So if this was angle R, I'll put the arrows. Kind of bugs me not having the arrows on there. If this is angle R and this is angle P, what do you think I can say about them both? Well, they're the same measurement, right? So they must be, we talked about segments. If segments have the same measurement, then the segments are what kind of segments? Congruent segments. If these angles have the same measurement, remember how we did that little tick mark thing to show that the segments were equal? For angles, if I put this little arc right here and another little single arc right there, that tells me that both of these angles have the same exact measurement. So that means that angle R is what to angle P? Congruent. How do we show congruent? An equal sign with a little squiggle on top. Okay, that's congruent. So what does this mean? It means angle R is congruent to angle P. A lot of times in the book you'll see this. You'll see them put a little m in front of it. That little m represents the measure of. All right, so the measure of angle R is congruent to the measure of angle P. You'll see that sometimes. Actually, I tell you what, you probably wouldn't see it in this situation. You would see it like this. You would say the measure of angle R is equal to the measure of angle P. Do you see the difference? Congruent means if the two angles are congruent, it means they have the same measurement. Right here, they just tell you the measure of angle R is equal to measure of angle P. All right, I know that's kind of weird. It's a little bit strange, but let's do one more thing. Let's do this. Got a few minutes left here. Let's talk about, and we talked about this a little bit. So, and I said later on we're going to do a little bit more with it. Well, it's later on. All right, so we are going to, remember this from the other day? All right, we talked about interior angles, exterior angles. Okay, so let's do this. This is N, this is M, K, and P. This is K, and this is P. All right, and we talked about the interior angles, exterior angles, that kind of stuff. This is another thing. This is This can be pretty important for some definitions we're going to do later on. So what if I had, let's just use the word.
Elena Valley to the office for dismissal. Nathan Valley to the office for dismissal. Thank you.
All right. We're going to call these adjacent angles. What does that mean to be adjacent? Here's another word that can be used in regular life, not just talking about angles, but the word adjacent. Again, kids don't usually say this, but you might talk to an adult and they'll say, oh, where's your room? Oh, I'm adjacent to the cafeteria, or I'm adjacent to, Mrs. Smith's room or something. It means next to, exactly right. So if I say I'm adjacent to something, that means I'm next to something. So what angles look adjacent to each other, next to each other? Oh, by the way, I didn't say this. I should have. My bad. I'll just do it right here. See this angle right here? No, I think I did talk about this the other day, didn't I? Talking about measuring, making sure the vertex is in the middle. Yeah, so I did talk about this. So that red one right there, what would I name that angle? Don't start at N, but yeah, start at M and then go where? N to K. So that red one would be M, N, K. Would you agree? All right. And what about this? I'm going to put two arcs here. I'll even make it a different color. What would I call this little skinny angle? KNP. Or you could go the other way too if you wanted to. You could call it angle PNK if you wanted to. All right. So those two angles are what? Adjacent angles because they're right next to each other. Make sense? But they have more of a little complicated definition. Here's what the definition basically says about angles. Let me see. Let's do this. Yeah. There's two things. Let me go back to white. There's two things that must be true for adjacent angles. The two angles must have a common side. We're going to look at both of these things. And they should have no common interior points. You're like, what in the world does that mean? No common interior, I'll put just INT, and then points, I'll put PTS. Is that right? So first of all, let's look at the red one and let's look at the green one and decide if they are adjacent to each other or not. Do they have a common side? Does the red angle and the green angle have a common side?
Yes.
Which one is it? What is the side?
K.
It's not just K, K's a point.
NK.
NK, all right? Ray, it's a ray, right? So ray NK is the common side. So that's one thing that's true about them. It says no common interior points, which means if I have a point inside the red one, can it also be inside the green one? The same point? No, there's nowhere I could put it, right? If I put a point in here, is there any way that this one is going to be inside this one? There's no way. Now, if I put it right on top, then it's not in the angle, is it? All right, it's on the ray. All right, so that wouldn't work, okay? And it wouldn't be an interior point, would it? So does it work for both of these? Yes. So are these two angles adjacent angles? Yes, they are. What about this, though? Here's the question. What about angle MNK and there's another angle here. What's the other angle? MNP. Very good. MNP. Do you see that? And let's make that a different color. Let's make that yellow. I'll just make a big old yellow. So look at the red one. That's MNK. And look at the yellow one. That's MNP. First of all, do they have a common side? Does the red one and the yellow one have a common side?
Yes.
They do. NM, right? So NM is part of that red one, and NM is also part of the yellow one. So that checks that off, doesn't it? What about this one, though? It says no common interior points. Well, look, if I put a point right there, that's in the yellow angle, but it's also where else? It's in the red one, isn't it? Okay, so do I have no common interior points? No, because this would be a common interior point. So that doesn't work. So is the red one and the yellow one adjacent angles? No, they're not. Okay, what about the green one and the yellow one? They're not adjacent as well, because if I put a point right there, okay, that's in the yellow one and it's in the green one. All right, and you can't have that to be an adjacent angle. Make sense?
Yeah.
Okay, we're almost done. I think we got one more thing. Oh, here's one more thing. Let's call this angle 1. Let's call this angle 2. Let's call the whole thing angle 3. So if I took the measure of angle 1, whatever it is, all right, and then I added it to angle 2, whatever the measure of that is, what's it going to add up to? To angle 3. That's right. Does that make sense? So angle 1 plus angle 2 equals angle 3. All right, with that said, we got one more example and we will be finished. So let me draw a picture that kind of looks like the last one, but just a tad different. Whoops. They actually make this like that. All right, so here we go. This is angle 1 right here. This is angle 2 right there. Put the arrows. Looks weird without the arrows. And this is A, B, C, and D. So here we go. We're going to do a little bit more math. It says find angle 2. Or it doesn't say just find angle 2. It says find the measure of angle 2. That means we're going to find a number, okay, when it says find the measure of it. And angle BAD, that bad angle. All right, angle BAD, here's what they tell you. If the measure of angle 1 is equal to 55 degrees, and they also tell you, right here, they tell you that angle 1 equals angle 2. And that should be all the information we need in order to find this angle and the BAD, which is the whole angle. So once I find angle 2, you know angle 1 then, don't you? Why is that? Because they're the same. They're equal to each other, all right? And if I find them both, then all I do is just add those together, and I got angle BAD, don't I? All right? But what's the problem? It's really not much of a problem. So we know angle 1. What's angle 1? 55 degrees. If these two angles are equal to each other, what's true about angle 2? See how easy this is? That's 55 degrees. What are they asking you for? Well, you just found angle 2, which was super easy because it's just the same as angle 1 because they told you. This is what they told you. Okay, I didn't just like figure that out on my own. They told me that angle 1 and 2 were equal to each other. Does that make sense? All right, and so if they're equal to each other and they told you angle 1 was 55, angle 2's got to be the same thing. So how do I find angle BAD? Just add them together. That's right. And what do you get? 110. So the whole angle is 110 degrees. Really easy. The math was super simple. But it's getting that concept, getting the idea that this angle plus this angle equals that whole big angle. Okay? They call that the addition, the angle addition postulate is what they call it. Postulate is just a fancy word to mean it's like a rule, a law, something that they tell us, okay? And that's basically it. What do you think? All right. I gave you the lesson plans at the beginning of class, but I will write down the lesson or the homework for you just so you remember. So it's section 1.5. It's pages 27 to 29. All right, now you got to watch carefully. I believe this is it's on fax. You can always check yourself. If you took a picture of the lesson plans at the beginning of class, it should be the same thing. And then 34 to 45, all right? Looks like a lot, but I split up a lot. I skipped a lot. You see that? From 15 to 20, I skipped. 29 to 33, I skipped. So that's basically what you're doing. Everybody good? If you want to get your phone out and take a picture of the homework, it's over several pages. You might have to take 2 or 3 pictures. Feel free to do that, but put your phone away as soon as you do that. And that's your homework. That's it.